So said, for simple harmonic motion, I'm done with almost all the questions from throw sheet 1, 2. Yeah, throw sheet 1, 2, and then with explanation. There's explanation on its own for simple harmonic motion, as well as the questions from past papers and the questions from the throw sheet. They just combined. Okay. And also some questions, I just got them somewhere. I think they are going to help you. Okay. So if you want to access all of them, it's just a matter of you um, downloading the app, and then you'll be able to see them. Okay. So for today, we'll solve tutorial sheet 3. If you have chance, we can even finish it, but I don't think it's going to be possible for us. So I know that some questions I solved them. Okay, some questions I solved them, so I'll be able to share the videos after this class. So there we go. We start with question 1. Question 1 is saying the wheel the wheel in the simplified engine of figure P13.23 has uh, radius which is A is equal to 0.25 meters and rotate with angular frequency of 12.0 rad per second. At t is equal to 0, the position is located at x is equal to m. Calculate the piston's part A position, part B velocity, part C the acceleration at t is equal to 1.15 seconds. Now, this question, sometimes you might be confused to say only part C is the one which is saying at t is equal to 1 point. They're just telling you to say find the position, the velocity, and acceleration at t is equal to 1.15 seconds. Meaning that part 1, part A, part B, and part C, we need to use the time which is going to be 1.15 seconds. It doesn't mean that only part C, that's where we're supposed to use t is equal to 1.15 seconds. No. It is saying calculate the piston's speed, or this position, velocity, and acceleration at t is equal to 1.15 seconds. So this one, 1.15 seconds, it is for both A, B, and C. You get my point, right? Are you getting me? Yes. So now what we're going to do there is whenever we're talking about if you have been given the angular frequency, what else? We have been given the amplitude. What we have to understand is that the formulas which we are going to be using here, if something is rotating, meaning that we are comparing, this is the relationship between circular motion and simple harmonic motion. So remember, we have those three formulas. Now to review, if you can remember those three formulas, you can just help me with, last time we came up with these three formulas, but I'll not explain on how to derive these formulas, but you need just to know them. We said the position as the function of x, as the function of time, it was equal to what? Those who can remember, let's do first. Those who can remember, the position as a function of time is given by guys, uh-huh, those who can remember, yes, yes, Mwape. Mm-hmm. Frequency times time. Okay, thank you. So this is the formula which we use for the position as a function of time. Now what it means there is that this A is the amplitude, okay, and we've been given the amplitude. Now last time I explained to say whenever we are talking about the angular frequency, sometimes they're not going to give you this. This angular frequency is also known as 2 pi over what? Over period. But we know that this one we can put it in this form. 1 over period. 1 over period is the frequency. So it's going to be this. Sometimes you're going to see this formula as x as a function of t a cos 2 pi f times t. This is just the same thing because this guy here, it is showing you that this part here, it is just basically this part is the angular frequency. You get my point, eh? So in a case where they are not going to give you this, now when plugging in the values, yes, you've got a question. Okay, when you're plugging in the values, remember the angular frequency is in Rad per second. Rad meaning that you need to change your calculator to Rad, from degree to Rad. Okay, so this is supposed to be, so now since we have the angular frequency, we're going to use the same formula. Okay, then now for the velocity as a function of time, we know that we need just to differentiate this. If I differentiate this in terms of the angular frequency, we discover to say this is going to give us negative a, then we are going to have this, then sine what? Sine this. Okay, at the same time, if again I differentiate this, I'm going to get acceleration, which is going to give me this. It's going to give me a, then this has to be squared because this is going to come here, then we're going to have this. So these are the formulas which you need to know. These are the formulas which you're supposed to know. So we call this the relationship between the simple harmonic motion and circular motion. But in the app, the videos which I'm going to upload today, I explained on how these formulas they are coming about, because we need to understand whenever an object is moving around the circle, so it is coming from here. Okay, so I'll not explain that because of time, but you need just to know that these are the formulas which we are talking about. So we are going to solve part 1, which is part A. The position as a function of time, the time is 1.15. I'm going to put it there. The amplitude is 0.250. Then we are going to have cos. Then the angular frequency, it is 12.0 times the time is 1.15. Those having calculators, remember we need to you need to change your calculator. Is supposed to be in Rad, not in degree. So I'm going to change my calculator to be in what? To be in Rad. So I'm going to say 0.25 cos, open brackets, 1, is it 120? It is 12.0 times 1.15. I cross the brackets. Okay, I'm getting 0.083. Confirm with me. I'm getting 0. Are you getting me? Patricia?
Yes.
Okay. So I'm getting, the answer I'm finding is 0.08 is 27, but this is just the same as it. So the answer is going to be, this is the, we're talking about the position. So what would be the SI unit? It's going to be in meters. Okay. Now, what we need to understand, guys, is that You can write this answer, since if you check here, they are giving they are giving us this one to be the position here, this to be in three significant no three decimal places. So you can leave your answer in also at three decimal places. You can say 0.083 meters. That is just okay. You can, or if you want, you can leave your answer in scientific notation. That is just okay as well. So that is it for part A. Can we go to part B? Or do we have people who are behind? Do you have people who are behind? Okay. Since Lisa is just quiet, meaning we don't have people who are behind. Yes, please. David.
Why are we using T to be 1.15?
We have been given the T to be 1.15, Lisa.
Oh, so I have to get the same one which is on C to use it on A.
Yes. The question is calculate the piston's position, velocity, and acceleration at. It's just a continuous at t is equal to 1.15 seconds. So this t is for both part 1, part A, part B, and part C. The 1.15
All right,
seconds.
thank you, sir.
Sure. We have v as a function of time. It is given by negative a, the angular frequency, sine angular frequency times time. Let's go ahead and plug in the values. V 1.15 is going to be equal to negative, the amplitude is 0.250 times, the angular frequency is 12, but it is in rad per second, so this has to be sine, then 12 times 1.15. So what I would like us to do is we first do this. We first find this on its own, okay, which is going to be I'm going first to say um, remember the calculator is supposed to be NAD. 0.250 times 12 is giving me 3. So I want us to say this is going to be negative 3, then we have sine 12 times 1.15. Okay, meaning that V as a function of time is going to be 3 sine open brackets 12 times 12 times 1.15. I close the brackets. So I'm getting my answer to be 2.83. I don't know if that is the one you're getting. Confirm with me. What are you getting? So you don't have calculators, which is bad. Who has got a calculator? Lisa, you don't have calculator? Lisa, you don't have a calculator? Messi,
I misplaced my calculator.
so you don't have a calculator?
Yes, sir.
No, guys, you can't be attending classes without calculators.
Okay, sir, let me look for it.
Yeah, look for it. So now, the answer I'm getting here is 2.83. Those having calculators, you are going to confirm. You cannot be attending classes for physics without calculator. That that doesn't make sense. So it is negative 2.83. So velocity is always in meters per second. So that is it for part B. Okay. We can go to part C, where we said the formula for part C The acceleration as a function of time, it is given by, or I can put this here, maybe you might need it. Put it here. The acceleration as a function of time is given by negative this square times a, then cos this. So if you don't want to forget these formulas, you need to know where they are coming from. That is very, very important. If you know where they are coming from, it's going to be very much easy for you now to do what? For you now to remember these formulas. Okay? In a case where you are having some challenges on how to swatira them. Okay, so we have 1.15, and then we have got this. So this is going to be 12 squared times 0.250. We have cos 12 times 1.15. Those having calculators? So we say 12 squared times 0.250 is giving me 36. So negative 36 cos I can also say inside there I can say 12 times 1.15, which is 13.8. And then acceleration as a function of time, which is 1.15, is going to be negative 36 cos open brackets 13.8. I'm getting negative 11.9.91 meters per second squared. Any question? Any question so far? Any question? Sorry? What are you saying? Your voice is too low. I can't get you. At why are we getting what? At why are we using 12 instead of 1.0? Which 120 are you talking about, madam? You're talking about this one? No, it is 12. It is 12.0. No, and not 120. Yes. Hmm? You have seen it, team. Okay, we continue. So we can say we are done for this question. We go to the next question. So the next question, let's see. Here is our next question. The sinusoidal wave shown in the figure below is traveling in a positive x direction and has a frequency of 18.0 hertz. Find part 1 the amplitude, part 2 the wavelength, the period, the speed of the wave. What is our amplitude? We did this. Messi is no longer here. Messi is here. Ratio.
Yes, sir.
Yes, what is our amplitude? How do we find the amplitude? How do we find the amplitude? Yes. Yes, Messi.
Okay, so for the amplitude, you're supposed to divide 8.26 divided by 2.
8.6. 8 point what?
8.26 divided by 2, that's the amplitude.
So Messi is saying we need to say 8.26 divided by 2. That will be our amplitude. So if we get that, 8.26 divided by 2, we are getting 4.13. So Messi is saying 4.13 centimeters, right? Centimeters is our amplitude. Are we supporting her answer or we are not supporting? We are supporting.
Right, Patricia speaking. It's me who's
Oh,
speaking.
it's Patricia. Oh, sorry. Are we supporting Patricia's answer? Hmm?
Yes.
Okay. That is just okay if we are supporting Patricia's answer. Okay, now amplitude, for the sake of let me just explain a bit. Amplitude, whenever we're talking about amplitude, is if I have got a wave, this is my wave here. So it starts from there. Okay, so if this is 1, or let's say this is 3, and then down here is also negative 3. So the amplitude is from here all the way to the equilibrium position there. So that is our amplitude. So if we can check here, the position from this point all the way to this point, or you can say the position from this point all the way to this point, or you can say the position from this point all the way to this point. That is our amplitude. So we can from this top part here all the way to bottom part here, it is what, 8.26. So now this 8.26, what we have to do is we need to divide it by 2 for us to find what, the top part only. So that's the reason why we said 8.26 divided by 2. That is it for part M. Then find the wavelength. If you have been given a wave like this, how do we find the wavelength? Yes. Uh, Let me just put the amplitude here, since we are saying that the amplitude is 4.13 centimeters. Okay. So how do we find the wavelength? Let's go. How do we find the wavelength? Hmm?
Okay, so for the wavelength, it's 5.20 times 2, because we said wavelength is distance between two successive troughs or crests.
Exactly. So wavelength, it is from this point here. If I have this, let me just give you here, and then I have something like this. This is 1. Okay. So from here, let me just say from let me another one. Then I have this. So from this point all the way to this point, that is our wavelength. Okay, that is our lambda. So in this case, we have been given that from this point here all the way to this point. Now, from this point all the way to this point, that is one. That is successive crest, right? Okay. So now, since we know from this point all the way to this point it is 5.20, so if we do times 2, meaning that we are going to get the what, our wavelength. If they ask you to say, okay, yes. If they ask you to say, now in this case, okay, let me just put something like this. I want to ask you another question. If I give you, let me say, I put this point here, I put maybe negative 0.5, okay? Then here I also put 0.5. Then here let me put 1. Here I put 1.5. Now I ask you to say what is the phase shift. What will be our phase shift in this case? Hmm? What will be our phase shift? Hmm. Messi, Lisa, welcome back. What is our phase shift? Okay, let me give you this. Let's say we have this. This is what we have. Let's say our wave start from this point. Our wave start from this point. It goes there, it goes there, it goes there. So in this case, what is our phase shift?
5.20.
Okay, we are starting from here, Lisa. We are starting from this point. This graph which I've given, the wave which I've given you. What is the phase shift here? This one. What is our phase shift? What is our phase shift? Hello? Hey, people. It seems like Lisa's network is not stable. Okay. Anyway, so the phase shift is where the graph is starting from. So in this case, the graph has started from 0. The phase shift is 0. So here, I've put negative zero point 0.5. That's where the graph is starting from. That is our phase shift. Okay? I think you did this in trig. Now that is our phase shift. Now, since we don't have the question for phase shift here, allow me to go to the next question, which is asking us to find the period. Okay, so since we said the wavelength, we are going to say 5.20 times 2, which is going to give us what? Our lambda would be 5.20 times 2. I'm getting 10 centimeters. But C is asking us to find the period. how do we find the period? Since we have the frequency, period is going to be 1 over frequency. So period will be equal to 1 over, we have the frequency 18.0. So our period will be 1. Okay, our period will be 1 divided by 18.0. I'm getting 0.055 as our period. 0.055, which is the same as just this seconds. That is our period. Then the next question is asking us to find the speed of wave. How do we find the speed of wave? So to find the speed of wave, the speed is given by lambda times frequency. I don't know if you have forgotten this one, but we're not. So now the speed is going to be equal to the lambda. We know it, but we have to convert this guy into meters. How do we convert it? So 10.4 divided by 100, which is 0.104 times the frequency is 18. So V will be equal to 18 times 0.104 is giving me 1.872 meters per second. Unless you have got questions, you can ask. If you have questions, please ask. Do you have questions? Hmm? Do you have questions? We go to the next question.
Yes, sir.
Okay. If there is no question, let's go to the next question. Here's question three from the throw sheet. Three out of three. So the tension is maintained in a string as in the figure below. The observed wave speed is v is equal to 24.0 meters per second when the suspended mass is m is equal to 3.00 kgs. What is the mass per unit length of the string? But b, what is the wave speed when the suspended mass is 2 kgs? So we're now talking about the speed of wave. Okay, so what you need to understand here is a just simple thing. The speed of a wave is given by the square root. We also derived this formula, if you can remember, if you were there last time when I was talking about this, the speed of a wave. So it is given by the tension force divided by the linear density. Linear density is mass divided by the length. Now they want us to find the linear density, that is the mass per unit length. Okay, so we have been given the the velocity, this velocity we have. We also know the mass, but we know that the tension force is going to be the weight of this block which we have. So it's going to be, the tension force is going to be equal to mg. So ft will be equal to 3 times 9.8. I think it's going to be 49. 3 times 9.8, no, it's 29.4. 9.4 newton. So here is our formula. Okay, here is our formula. I hope you you are able to follow. Okay? Okay, so we continue from there. We are saying our velocity, we know that our velocity is 24. I'm going to put a 24 here. Are you still here? Are you still getting me?
Yes, we are.
Okay, we have 24 is going to be equal to the square root. The tension force is 29.4 divided by the linear density. Let's square both sides for us to get rid of the square root. Now what I have here is 24 squared is what? 24 squared is 57 point, no, 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 576. But guys, you are not supposed to be coming in class without a calculator, please. Mercy. So
I found it.
I'll cross multiply and then I'm going to find 257 times the linear density. Then we have this. So I'll divide both sides by 257, both sides by 257. What is our linear density? If you have found it, what is our linear density?
Yeah, 7 per meter. Is that what you are getting?
Sir,
Mm.
257.
I squared 24. 24 squared 5. Oh, is 576. Is 576 and not 250 something. Is 576 mu has to be equal to 29. We divide it by 576. 576. So our mu value, what did you find? What did you find?
Zero five one. 19.6. Okay. So that is it for question 3. Do you have questions? Do you have anyone who is still gallivanting? Anyone who is behind?
Anyone who is behind? No one. So for today we end here. We are remaining with two questions, if not mistaken. Yeah, we are remaining with two questions for Pro Sheet 3. Now, what I want us to do is, like I said, the app is ready. If you want to access Pro Sheet 1 to Pro Sheet 2 with other questions from past papers and other questions from some other documents, they are ready. I'll be able to upload after this class. Then you'll be able to access them. I believe those videos are going to help you for test 1. Okay? Then tomorrow I'm going to upload tutorial sheet 3 and 4 and also some other questions from waves. That is also very very important. Okay, so for today we end here. If you're having any questions, you can inbox me. Have a blessed night.